Hey, Dr. Seegren here, and today I'm going to show you a app I developed that helps show various statistical spatial analyses on patterns of vegetation across landscapes. So to use it, you'll have to upload a file of either a satellite image or of a plot of vegetation that you are wanting to determine statistics on. The first I'll show you is an urban environment. And it takes a second, but after a while it will show you. So this is a section of South Houston, and you can see that on the right we have three images. This is the base image on the bottom, and you can see it's a urban landscape with lots of roads, but also some parks and some wooded areas that are not developed. And let's say, for the sake of argument, you want to know how much of this is urban versus has some kind of vegetation coverage. We can look at the image and break it down into colors, and anything that is greenish will be highlighted, and anything that is not greenish will be highlighted pink here, highlighted blue. I used blue and pink because my dad pointed out I had green and red, and he's red-green colorblind, and so these colors should show up regardless of color blindness. But basically, the top image shows you what counts as vegetation, and so you can look at the areas that aren't blue and see if you're missing anything. And then this second image shows you what counts as urban or non-vegetation, and you can see if there's anything in it that looks fishy. Like, as I'm looking at this picture, everything that is not pink does look indeed like it is greenery. The default settings are pretty good, but if you want to adjust some thresholds, so for example, let's say we want this field here that's not concrete or building. Same with some of these fields around this airport and some of these grassy areas here. So we can adjust it to include, say, more brownish or bluish colors by adjusting these top two filters. So we'll do the top one. This one might not result in much in this one because I don't see a lot of bluish greens, but let's just adjust this. When you adjust it, it'll update your estimate, and yeah, actually it did highlight a bit more over here. And let's go ahead and do the brown as well. And so this will now include more browns, and you can see now that's including almost everything that could possibly be considered a wild area, whether it's a brownish colored field or anything like that. But that might be too strict of a definition for some people. Really, the only things that are being masked now are like the tops of buildings and roads. But well, it looks like some of the roads up here are being counted, so let's adjust that back. How these sliders work is any image, whether it's PNG or JPEG, has values for red, green, and blue. And if you set it to 0, that just means any value where green is bigger than red will count as vegetation. If you slide it to above 0, that will make it a stricter criteria, so you have to be really green. And if you move it below 0, that actually red can be bigger than green, which would potentially be a brown color. So we could say brown, and then we could also remove bright colors. So I could slide this down, and that will pull out more rooftops and roads, you can see. So in other words, what we're doing now is only including dark brown. That's actually looking quite good, but you do see that we have lost some of the fields around the airport because those are very bright browns as well. There's no perfect solution to things like this because very possible that the color of certain roads here in the top left are actually the same color as our brown field here. And so there's no way to distinguish the two from color alone. I think somewhere in there looks pretty good. And the last filter that you can adjust is to remove dark or light colored. This might be useful if there's a lot of lakes. For example, I believe this is actually a lake. And so we could remove it, but chances are we would have to remove a lot of other dark colored forest before we could remove those lakes. We'll see another image where the dark slider will be more helpful. Alright, so I think this is looking reasonably good. I think everything that's highlighted here is for urbanization, you might not be after forest, but just areas that are not developed versus developed. Particularly for something like drainage, urban areas that are covered in concrete are really, really bad for drainage and flooding, whereas if you have even open grasslands and parks and things like that, it reduces flooding considerably. So this would be a good indicator of how much urbanization has happened in this area. And yeah, the mixture of lawns and trees in these residential neighborhoods does actually help reduce flooding a bit. So when you're satisfied with what this looks like with these sliders, which I think I am now, you can hit Compute Landscape Statistics. Give it a second. It's running some complex data, so all right. And so now it will give us the percentage coverage. So of this urban area, 55.96% is covered by vegetation and fields, which you can also subtract that, so around 44% would be urban. This tells you how many different vegetation patches there are. So we have over 2,135 patches of vegetation. So every single one of these little patches will count towards that. This gives you the average patch size in pixels, as well as the largest patch size in pixels. If you happen to know how wide your image is, and you divide that by the number of pixels, that will give you a converter to real life square meters if you would like. Largest patch index, so if you take the largest patch and you divide that by the entire size of the image, this is the percentage of the image that the largest patch covers. So our largest patch covers 18% of the image. So we have a pretty big patch, probably this one here. And then the Gini coefficient is something that measures the inequality of patches. So if you have a smattering of even-sized patches, you would get a score closer to 0. And if you have a score closer to 1, that means that one patch dominates heavily. So our score is being pretty close to 1. That means that we have some really, really large patches and a lot of really tiny patches, very unequal in size. Moran spatial autocorrelation, we have 3x3, 5x5, and 7x7. So Moran's spatial autocorrelation is also a score from 0 to 1. 0 is an even distribution of vegetation, like imagine a checkerboard across the entire map, whereas a score of 1 would be just one single big blob all clustered together. So this kind of shows you how clustered the vegetation is. We're somewhere in between 0 and 1. That just means that it's not super clustered and not super evenly distributed, somewhere in between, which, yeah, the distribution of vegetation here is pretty scattered, but then there are some big clumps as well. Contagion index shows something similar as spatial autocorrelation, with a little bit more of a focus on interconnectedness. A score of 0 would mean you have a patchwork of non-connected patches, whereas a score of 100 means that you have either one big blob or everything's very well connected in your landscape. And that's looking across the entire landscape. Oh, the 3x3 and the 5x5 and the 7x7, the way Moran's spatial autocorrelation works is it analyzes a box of pixels, either a 3x3 box, a 5x5 box, or a 7x7 box, and analyzes the similarity of pixels and the distribution of pixels, and does that across your entire map, and so that's what that's indicating. There's no right or wrong one to use. It just gives you different information about the scale of correlation. Aggregation index is also similar to these other ones. Scale of 0 would indicate poor clustering. A scale of 100 would indicate a big blob. I believe this one works, it's basically what is the likelihood if you're a patch of vegetation or a pixel of vegetation that you are bordering another pixel of vegetation. So it's sort of a measurement of how isolated the patches are. And then finally, shape index. If a score of 1 is perfectly circular, and as the score gets higher, it's more irregular and non-circular, your patch, your average patch. So 1.37 saying this is mostly circular, but not perfectly circular. And yeah, we have a lot of sharp edges here and there, so that is a good indicator. And below that is my brief explanation of how all those work. So if you want to read up about them, you can as well. So that's a pretty neat tool. It works on a variety of environments. Urban, we can do a more rural setting here. So this is a rural environment. We have some farmland, we have some forests, we have a lake, and we have some urbanization as well, and some suburby looking things. This is one where, depending on what analysis you're doing, do you want to just count forest, or do you want to count forest and agricultural land compared to urban? This one is one where the dark threshold is very helpful, and the bright threshold is as well. Right now, we are including some farmland, but not all of it. I actually don't want to include farmland, I just want to look at forest. So here we can do the bright adjuster, and we can see that removes most of the bright colors of the farmland. And really what we're left with is these patches of forest. There may be a few. If we adjust the dark, we can remove almost all of that farmland from our image and really only include these patches of forest that are occurring along this river. There are some value. And of course all this is forests, and I believe this is clear-cut forest. And yeah, everything we have highlighted here is forest. There is a problem. Something like this lake here on the top right compared to this forest over here. These colors are almost identical, and most lakes actually do have a greenish hue to them because of algae within them, and so it is almost impossible to remove lakes. So I think this looks reasonably good for what is actually left of the forest. This is around the town of Bastrop in Texas. And so once again we can hit compute landscape statistics to see how many patches we have, the average percentage cover. Only about 25% of the forests are left in this area. And so this is a really useful tool if you have historical photos and you want to see how forests have changed over time. Of course, this number might actually be a little bit high because of this lake. Is probably adding a few extra percentage points. Something you can do if you have a problematic area like that, water is mainly what's problematic because a lot of water is just dark green. You can go into Microsoft Paint and just erase out that section of water, and so it's white, and then it'll be filtered out. Here we can see Moran's index has gone up. That just means that this is less evenly patched. These forests are highly fragmented and not really evenly spread out, and so that's what this is giving us. Strangely enough, the contagion index is a bit higher than the last one. That's just saying that so the forests that are left are actually reasonably well connected and blobby, but there's just not as many of them. So yeah, you can really get some very interesting information from this landscape statistics. So I pulled an image from mountains in this is in New Mexico, which have been somewhat developed by roads. We can see here's the original picture. We see some sporadic forest and some denser forest, as well as in here. And so this is where it gets kind of tricky. If you have some more information about land, I imagine that this area, there is a smattering of green, but this is probably more shrubland and junipers, and then these greener areas are more forested. So actually this is looking pretty good in terms of what counts and what doesn't count if you want to be very strict. If we want to be less strict, we could include some of these more brighter colors, and if juniper forest still counts as natural ecosystems, we could adjust our brightness filter back. And now you can see we're pretty much including everything that is not a road and that's not a strict development area. I believe this is a part of New Mexico mountains where I don't think these are actual homes. I think this looks like it might be either mineral or oil development. And so if you just want to see what was the impact of landscape impacts of this network of roads going in, then you could use that. Yeah, some of these areas definitely don't have any kind of wood. So I think that looks pretty good. And like I said, this one is going to be mostly vegetation. So the impact of those roads and that development just reduced the landscape coverage by, maybe 10% or so. And yep, still pretty well connected and pretty well evenly distributed. And so the impact of these might not have been too significant. The biggest problem here is something like this landscape, where this is a salt marsh in Galveston Bay, and like I've mentioned before, a lot of times water has algae in it and it will be a greenish hue. So if you are trying to be very strict on just measuring salt marsh coverage in this area, we may have to be really careful with some of these greener waters. So right now, according to these thresholds, everything is pretty much considered salt marsh, which is not ideal. So let's see if we can play around. This time, I think being more strict with our teal definition could be helpful. Yep, so that's removing some of these water patches. And also, the water tends to be brighter than the vegetation. The marsh vegetation is pretty dark, so I think we can remove some brights, perhaps. Oh, now we're seeing that that's working pretty well. this is highlighting mostly just the vegetation now. We can see there is still a patch of water here and in this corner. So this water and this, and you can see that's really greenish in color. So I end with the least impressive example of this technology, which is dark green water, very challenging to filter out by color alone. So what I would do is go into Microsoft Paint and just erase this top corner and erase part of this main channel. No more problem. Alright, so I've uploaded my new file. Now we have those those white areas blocked out, and this looks better. We don't have those false positives anymore. I think everything that's highlighted here looks pretty marshy. Yeah, only 37% of this, 36.57, is covered in salt marsh. And so if you're looking to look at the benefits of ecological restoration over time for an area and how much salt marsh is accumulating or disappearing, this is a very useful tool. But you might have to clean up the image slightly, especially with these greenish colored bays and channels. I hope maybe some people can get some use out of this. And this is made in our Shiny package, so that's I'm blown away at the functionality of what that package can deliver. I may update this to have an export feature so you can export this these images and data into some kind of document. Thank you for watching. Hope you get some use out of it.